Good evening, everyone. This is the assignment related to bonding and shapes of the molecules. So we'll discuss some questions related to the molecular part, predicting a geometry. About the polar and non-polar, that you will study in Unit 2. That's why I did not go in detail. So this question is about the structure of substance. What we have to do, predict NH bond angle and NH in NH4 and HOH bond angle in H3O. So how we can predict this? So first, whenever we want to predict, so we have to check the geometry. We have to check the structure. So when you have NH4, I will use the space to draw NH4. As we already did for NH4, so nitrogen belongs to group 5, it will share 3 electrons. And one of the lone pair of a nitrogen is attracted towards, so there's a dative bond. But when we are predicting a geometry, we consider that dative bond as a covalent as well, because that's a sharing of electron. So it will have bond pairs. The number of the bond pairs are 4, and about the lone pairs, that is 0. So if we have 4 bond pair and we don't have any lone pair, then you can see from this table that bond pairs, 4 bond pairs and no lone pairs, so it will be a tetrahedral. And we have to predict the bond angle. So as it will be a tetrahedral, so the bond angle will be 109.5 degrees. So the first answer, it will be 109.5 degrees. What about the second one, hydroxonium or H3O? So first, again, you have to draw the structure to identify the bond angle. Actually, what happened in water? There are 2 bond pairs and there are 2 lone pairs. This is what happened in normally water, but because it is H3O with a charge plus, so means there is one more proton is added, so this H is added, so there's a dative bond. 2 of the bonds are covalent, but one of the bond is dative. But when we predict the geometry, we consider that as a bond pair. So how many bond pairs appear here? 3 bond pair. How many lone pairs are there? That is equals to 1. So if 3 bond pairs and single lone pair, predicting a geometry with 3 bond pairs and single lone pair, so it will be trigonal pyramidal with a bond angle of 107. So what will be the bond angle? The initial, this was tetrahedral, so 109.5, and here it is 107 degrees. It's of 2 marks. In a short time you can do this, but because this is the first time you're doing the assignment related to this part, so that's why I explained the structure. Then name the shape of BF3 and PH3 molecule and explain why they are different. So it's a 4 marks. First, BF3 boron belongs to group 3. Boron even belongs to group 3, but because of its small size, it is not able to transfer all of its electron. That's why it tends to share. And it is not able to complete octet here. So there are some elements with exception. So what is having, this is having 3 bond pairs. and it is having zero lone pair. So when we have 3 bond pairs and 0 lone pairs, then the bond angle will be 120 and the shape is known as trigonal. What about pH3? Phosphorus belongs to group 5, so it will share 3 electrons. It's same like ammonia. So it is having 3 bond pairs and it is having 1 lone pair. So when 3 bond pairs are there and 1 lone pair, that is same as the structure of ammonia NH3. So 3 bond pairs and 1 lone pair, we call that as a trigonal pyramidal, and 3 bond pair we call trigonal planar, or trigonal is also acceptable. So in pH3 the bond angle is 107, whereas BF3, that's already shown in the example, that bond angle will be 120 and the structure will be trigonal planar. Then they ask for the reason that why they have these structures. So 1 mark is for mentioning that pH3 will be trigonal pyramidal, whereas BF3 will be trigonal planar. And you will mention that in pH3 there is a lone pair, so it will have a greater repulsion. That's why the bond angle will be smaller. So in pH3, 1 lone pair and 3 bond pairs having more repulsion compared to BF3, which has only which has 3 bond pairs and no lone pair. Or you can say BF3 will have low electron density as compared to pH3. Is it clear? So 1 mark is for mentioning the geometry, what we already did, and the second mark is for the comparison of the lone. The total, even you can compare the total number of electron pair. So total number for PF3, pH3, the total number include the lone and the bond, that is 4. Wherein in BF3, the total number of pairs is equals to 3. So as the total number of the pair changes, that's why the shape of the molecule also changes. The next question they're asking, explain why the bond length of chlorine is 0.199 nanometer, but for iodine it is 0.26. So what is the reason why for iodine it is having greater bond length? So it depends on the size as well. As you can see, the iodine is having more electron shells and greater shielding effect has more electron in the inner shell, so it will have a greater shielding effect, and it has less attraction between the nucleus and the bonding electron. That is why the size of the iodine I2 molecule is much larger as compared to the size of chlorine molecule. Another question suggests how dot and cross diagram for chlorate 7-ion. So we have chlorate 7-ion. Basically, what is the meaning of chlorate 7-ion? It means the oxidation number of chlorine is +7. So each oxygen is -2, 4 oxygen will be -8, and for chlorine will be +7. So the net charge on the chlorate ion is -1. That's why you can see a net charge of -1. We have to use a dot to show a chlorine electron and a cross to show oxygen electron, and a steric for an extra electron in one of the oxygen atom. So basically how this is done, first normally, for example, this is oxygen belongs to group 6, so it will share two electrons, and unshared will be 4. And chlorine belongs to group 7, so it will share 1 electron, and unshared will be 6. So we have to show how these, like there's a covalent molecule or covalent structure is there. And there is one extra electron. That extra electron we have to represent by a star or a steric. And the net charge, because there is an extra electron, so as there is extra electron, the net charge, that is -1. Now what happened? When we say chlorine is having a charge of +7, so this chlorine is actually transferring the electrons. When it is having a net charge of +7, it means chlorine is transferring the electron to oxygen, and it's a dative bond. So what happened, because we have to show that there are 8 electrons for this chlorine, so this is a dative bond in which both of the electrons are shared by chlorine. This is a dative bond which shows both of the electrons are shared by chlorine. This is also a dative bond which shows both of the electrons are shared by chlorine. And the oxygen, which is having 6 electrons, does not share its own electron. Actually, both of the electrons are coming from chlorine only. That's why total oxygen 8 here, 8, this oxygen 8. Then what happened? Because chlorine is having +7, so it means that it will transfer or share 7 electrons. So 6 are already done. This is the 7th one, and that it shared with oxygen. So there is only one There is one covalent bond, simple covalent, and remaining three are the dative bonds. And then we have to show by a star or a steric the extra electron which oxygen is having, which makes the net charge on this molecule as -1. Is it clear? The structure of chlorate molecule? Because if you try to share, if you try to draw in a normal way, you won't be able to. Like example, normally we know oxygen belongs to group 6, so it will share 2. So if this oxygen share 2, chlorine should share 2 from this side. Then what happened to the other oxygen? They won't be able to share or complete their octet, otherwise the chlorine will have more than 8 electron in the outermost shell. So we have to draw a structure which supports an idea that it is having 8 electron in the outermost shell. So how it can be done? When each oxygen is having 6 electron, their outer shell electrons. So when this chlorine dative bond shared both of its electron with one of the oxygen, then another oxygen, then another oxygen. But now this chlorine is left with one. So when it is left with one, oxygen will share only one from that side, and extra electron oxygen took from the surrounding. That is the electron we represent by a star. And that leads to a net charge on the molecule as -1. So ClO4 having a charge of -1 or -1. Is it clear, this example? Any doubts? So this is an assignment related to the bonding and structure. The next session means tomorrow. We'll discuss more questions related to bonding and shapes of molecule.